All right, so homework 38 starts off with creating an inconsistent system of linear equations. And if they're inconsistent, that means we have lines that are parallel because they don't cross and don't have a solution. So if my two lines are going to be parallel, they have to have the same slope. So what they're going to have you do is put it in slope-intercept form so you can then compare the two slopes. So I'm just going to rearrange both of these and solve them for y. So top one, negative 9y would equal, if I move my x over, it's going to be negative dx plus 4. Then, of course, I've got to divide by my negative 9. And so y is going to equal, I've got a negative over a negative, so that makes that a positive d over 9x. And then a positive over a negative, so minus 4 ninths. Then I'm going to go ahead and solve that second equation for y also, which doesn't have any weird variables, but just go ahead and rearrange it. So negative 15y is going to equal a positive 20x minus 17. If I divide by my negative 15, y is going to equal, I can reduce that down, so negative 4/3 x plus 17/15. So once we have them both in slope-intercept form, then what they're going to do is set the slopes equal to each other so you can solve for your variable. So d over 9 should equal negative 4/3. I'm going to put the negative on top with the 4, and then I can cross multiply. So 3d equals negative 36, and if I divide by 3, d would have to be negative 12. So if this was negative 12x minus 9y equals 4, it would be parallel to negative 20x minus 15y equals 17. So the second one there, again, we want to go ahead and rearrange those so they're both solved for y. So if we do the top equation, what would we do?
Subtract your 10x.
Subtract my 10x. So cy equals negative 10x minus 10. And then divide by my c. So y is going to equal negative 10 over c. X minus 10 over c is where does that look? The bottom equation, it doesn't look like they changed that much from number 1. If I solve that one, I'm going to have 12y equals, and on the other side I would get
15x minus 17.
15x minus 17. I then divide by my 12, so y equals 5/4 because I can reduce it down. You could leave it 15/12, but then your numbers are bigger, so I like to reduce it down. So 5/4 x minus 17/12. So now that I have my lines in slope-intercept form, I can set the slopes equal to each other. So negative 10 over c would be equal to 5/4. And so if we cross multiply that to solve that, we would get
5c equals negative 40.
5c equals negative 40, and dividing by 5, c is going to equal negative 8 then, right? And the third one there, if we rearrange that top equation for y, 8y would equal
Negative 6x minus 5.
6x minus 5, dividing by our 8, we then get
3/4.
negative 3/4 x minus 5/8. On our bottom equation, negative 20y is going to equal
bx plus 1.
Negative bx plus 12, we're going to divide by negative 20. So y equals
bx over 20 plus negative 3/4.
so negative 3, you divided by 4, right?
Oh, yeah.
Fifths then, right?
Yep.
Negative 3/5. Not that that would make a difference on this one, but we'll do some later where we will have to make sure we get that number right. So again, we want to set our slopes equal to each other. So b over 20 has to equal negative 3/4. So if we cross multiply and solve that, we would get 4b equals negative 60. And when you divide by 4, your answer is going to be
Negative 15.
negative 15. Now the next ones just add a little bit more to what we just got done doing. Instead of always wanting an inconsistent one, they might ask you if it's consistent dependent, consistent independent, or inconsistent. So we already did inconsistent. If it's inconsistent, the slope is the same. And I'm thinking ahead and trying to write without finishing my writing. The slope is the same. The y-intercepts are different. So these ones we're usually going to have two missing variables, and so we're going to have to do both the slope and the y-intercept. If it is consistent, dependent. Consistent dependent, those are the ones where it was one line right on top of the other line. Both the slope and the y-intercept are the same because it's the same line. And if we have the last kind, consistent independent, those are the ones where the two lines intersected in the point. Usually both the slope and the y-intercept are different. So, find two numbers a and b such that the following system of linear equations is consistent dependent. If it's consistent dependent, I want my slopes to be equal, I want my y-intercepts to be equal. So basically I'm going to start the same way, set them equal to y. So on the top one, negative 6y is going to equal 2x plus b, dividing by my negative 6. Y is going to equal negative 1/3 x minus b over 6. On my second equation, negative 2y is going to equal, that's going to be a negative ax minus 2. If I divide by negative 2, y is going to equal a positive a over 2x, and a negative over a negative is going to make that a positive 1. So what we're going to do is basically set the slopes equal, solve it, set the y-intercepts equal, and solve it. So negative 1/3 has to equal a over 2. So cross multiplying there. 3a would equal negative 2, so a is going to equal negative 2/3. I need more writing space. And then for the second part, I'm going to solve for b, so then I'm going to set my y-intercepts equal. So negative b over 6 has to equal 1. Cross multiplying there, negative b would equal 6, so b is going to equal negative 6. So a equals negative 2/3, b equals negative 6, if they're going to be consistent dependent. So number 5, same kind of thing. I'm going to set them equal to y. So 3y is going to equal, it's going to be a positive 4x plus 5. I'm going to divide by my 3. So y equals 4/3 x plus 5/3. On my second equation, 6y is going to equal, that's going to be a negative ax plus b. I'm going to divide by 6. So y is going to equal negative a over 6x plus b over 6. Now this one wants us to do an inconsistent system of equations. So for an inconsistent one, I want my slopes to be the same. My y-intercept is going to be different. So with my slope, the 4/3 is going to equal negative a over 6. So negative 3a would equal 24, and when I divide, a is going to equal negative 8. For my y-intercept, I want 5/3 not to be equal to b over 6. And so 3b we don't want to be equal to 30, so b cannot be equal to 10. However, they're not going to let you enter it in like that. What they're going to do is just have you put an answer in for b, and as long as you put an answer in that is not 10, it is correct. So you could just randomly pick out some really strange number like negative 3.445 and not solve it. We just know that b can't be 10. I can pick any other number. Hey, maybe I'm just going to pick 3, and then that's going to be okay. So you can put any number in other than what it actually solves for. So if you were doing consistent independent and they're both different, if you're really lazy, you could just pick 2 really weird numbers. And it should work. Let's see what number 6 says. Consistent independent. There it is. There's a consistent independent one. If I actually went through and solved this. So, solving my top equation for y, what am I going to do on that one?
2y equals negative ax plus b.
Keep going. Divide by 2, so y is going to equal
Negative a over 2x plus b over 2.
my second equation. Solving that one for y. Hey, that one's an easy one to solve for y.
Y equals negative 5x plus 6.
So, for my slopes, since I'm doing consistent independent, I don't want my slopes to be equal, and I don't want my y-intercepts to be equal. So negative a over 2 should not equal negative 5. B over 2 should not equal 6 then. So negative a can't equal negative 10, so a can't equal 10. What do we want a to be equal to then? 3. Anything that's not 10, right? B can't equal 12. So what do we want B to be equal to? 3. Anything that's not 12. There's my answer set. So you hope they ask you that one. Even if you did the problem wrong, there's a pretty good chance you still might get the right answer. So, consistent, dependent, they're both the same. Consistent, independent, they're both different. And inconsistent, the slope is the same, but the y-intercept is different. And now we're going to get into a whole bunch of application problems of how we might use systems of equations to solve word problems. First one says the sum of two numbers is 42. The larger number is 2 times as large as the smaller number. What are the two numbers? So I'm going to use L and S just because I like to use variables that make sense. The sum of my two numbers, L plus S equals 42. The larger number is, so I'm going to let the L equal, whichever one is mentioned first, that's the variable that's by itself. So the larger number is 2 times as large as the smaller number, 2 S's. On this one, since they put the large one in terms of the small one, substitution is probably my easiest way to solve it. So we're going to replace the L with our 2 S's and say 2S plus S equals 42 then. 2S plus S would be 3S equals 42, and when I divide by 3, S is equal to what? 14. So I know my small number is 14. I still need to find my larger number. I could substitute in either equation, but since that one's already solved for L, I'm just going to take 2 times 14. And so my larger number is 28. And if we wanted to really double check ourselves, we would say, oh, the sum is supposed to be 42. If I add my answers together, do I get 42? Sure enough, I do, so I probably did it right. Number 8 says the sum of two numbers is 61. So it starts the same way. The large one plus my small one is 61. This one says the larger number is 7 more than the smaller one. So L would be equal to what?
S plus 7.
S plus 7, exactly. Again, we can solve this by substitution. We're going to get rid of the L and put S plus 7 in its spot. So S plus 7 plus S equals our 61. Combining my like terms then, 2S plus 7 equals 61. If I minus my 7, 2S is going to equal 54, and if I divide by 2, I'm going to get 27. So S equals 27 for my small number. My large number. My large number was 7 more than my small number, so 27 plus 7 would give me 34. And again, if I added my two numbers together, I should get a sum of 61, which I do. Number 9 says the sum of two numbers is 46 and the difference is 12. What are the numbers? So sum of two numbers would be
46.
L plus S equals 46. If my difference is 12, I would have exactly. Difference means I'm subtracting, so L minus S equals 12. Since I didn't have one written in terms of the other, I have it in standard form, probably the elimination method is the best way to go about solving this one. Here I already happen to have opposites in front of my S's, so I can just cancel those out when I add them together. So L plus another L would be 2L. The S's cancel out. 46 plus 12 is 58. And so when I divide by 2, I get 29. 29 is my large number. I want to find my small number. Again, I could substitute into either equation and solve, but usually the one with the plus sign is easier to do than the one with the minus sign. So 29 plus S equals 46. And if I subtract then, S equals 17. So I should be able to add my two numbers together and get 46. And if I subtract my two numbers, I get 12. Yep, I do. 10, 11, and 12, we are solving value mixture problems. Says 2 rainstorms occurred in 1 week in a certain area. The first storm, 40 milliliters of rain fell per hour, and in the second storm, 25 milliliters of rain fell per hour. The rain lasted for a total of 55 hours, resulting in a total rainfall of 1,825 milliliters. How long was each storm? So, how long was the first storm? We don't know. We said it's F. How long was the second storm? We don't know. We say it's S. So the length of the first storm plus the length of the second storm should be the total length of the 2 storms, 55. On these ones, they're usually always going to have one of them where you have A plus B equals or F plus S equals with nothing in front. The other equation is going to come from the number of milliliters that fell. If I take 40 milliliters times the length of the first storm, I have the total amount of rain for that storm. So 40F. If I take 25 milliliters per hour times the length of the second storm, I get the total rain from the second storm. So if I take the rain from the first storm plus the rain from the second storm, I should get my total rainfall, 1825. Now on Alex, they're going to set up the 2 equations if you look at the explain, but they're not going to solve because some people like to solve by substitution, some people like to solve by the elimination method. I prefer the elimination method, but that's just me. What's your preference? Elimination. And since we have to find both the F and the S, it really doesn't matter which variable we cancel out. Do you want to get rid of the F or the S?
Yes.
The S. So I'm going to take the whole top equation times a negative 25 so that I have opposites in front of my S's. So using my distributive property, negative 25F minus 25S equals, and then if you'd multiply negative 25 times 55 for me.
Negative 1,375.
1,375. So adding my equations together, 40 minus 25 is 15F. The S's are opposites, they're going to cancel out. 1825 minus 1375. $450, and then of course we have to divide. $30. So the first storm lasted for 30 hours. That was a long storm. We have to find the length of the second one. We know that the first plus the second was 55. So if we go ahead and just subtract, the length of the second storm is 25. Number 11 says, 2 mechanics worked on a car. The first mechanic worked for 20 hours, the second mechanic worked for 15 hours. Together they charged a total of $3,950. What was the rate charged per hour by each mechanic if the sum of the 2 rates were $225 per hour? So we're finding the rate of each of my mechanics, right? How much did they each charge per hour? My first equation might be what?
F plus S equals 225.
Exactly. The rate of the first plus the rate of the second was 225, the sum of the 2 rates. My second equation has to do with how much they charged altogether. If the first one worked 20 hours and the second one worked 15 hours, together they charged $3,950. So what would my equation for that be?
Yeah, plus 15, that equals 3,950.
Exactly. 20F plus 15S equals 3,950. And do we want to use the elimination method again or a substitution method?
Elimination.
Elimination, I think that's easier too. And what should we multiply the top equation by?
-20.
-20. We're going to get rid of our f's this time. So, -20f minus 20s equals, and what's -20 times 225 then?
-4,050.
-4,050, so 4050. 20s are going to cancel out, or the f's.
Wait.
Oops.
It's -4,500.
-4,500, okay? We'll fix that before we get to the end. All right, -4,500. Vada's supposed to yell if she has a different number. I think she's still sleeping. So, -5s is going to equal 3,950 minus 4,500.
-550.
-550, and if we divide by -5, we get 110. I'd like to make $110 an hour. I don't make anywhere near that. I should have been a mechanic. Second one made 110. We knew the first plus the second was 225. So how much did the second one charge?
150.
150. Think they really charge that? Maybe in big cities. You know, the people who wrote this stuff's from California. Maybe they charge that in California. And just buy a new car. Number 12, a family has 2 cars. The first car has a fuel efficiency of 35 miles a gallon of gas. The second has a fuel efficiency of 30 miles per gallon of gas. During one particular week, the 2 cars went a combined total of 2,425 miles for a total gas consumption of 75 gallons. How many gallons were consumed by each of the 2 cars that week? How many gallons? So if my question is how many gallons were consumed by each of the 2 cars, what could I have for my first equation?
Plus S equals 75.
First car's number of gallons plus the second car's number of gallons is the total of 75 gallons. It said there, right? My second equation, what would my second equation be?
35F plus 30S equals 2,425.
So if this car goes 35 miles a gallon and it used F gallons of gas, that would tell me how many miles I drove that car, right? And so forth. So I'm going to assume we're using the elimination method again. Do you want to get rid of the F or the S?
Yes.
The S? Then I don't have negative numbers. If I use the smaller number, multiply everything by -30 then. -30F minus 30S is going to equal -30 times 75.
-2,250.
2,250. So we're going to have 5F. S's are going to cancel out. 2425 minus 2250.
175.
175 divided by 5. Then.
35.
35. first car used 35 gallons of gas. How many gallons did the second car use?
40.
All right. 13, 14, and 15, this time we're going to do percent mixture problems. Kind of the same thing we just got doing, but this time we've got percents in there. It says a petroleum company has two different sources of crude oil. The first source provides a crude oil that is 50% hydrocarbons. The second one provides crude oil that is 75% hydrocarbons. In order to obtain 120 gallons of crude oil that is 65%, how many gallons of crude oil must be used from each of the two sources? So, how many gallons? How many gallons? So same kind of thing here. If I take the number of gallons from the first source plus the number of gallons from the second source, I had 120 gallons, right? My second equation is coming from the percent. The first one is 50% hydrocarbons. So if I do 50% of F, I would get whatever hydrocarbons are, how many hydrocarbons I have. The second one is 75%. So if I do 0.75 S, on the other side, I'm doing 65% of my total to find the total number of hydrocarbons. So I'm going to have 0.65 times that 120. So probably, obviously, the first thing I want to do is go ahead and multiply that out so I get a number there on my equation. 65% of 120 would be 78. So now again we have our two equations. We could solve by substitution, but I would probably use the elimination method again. If I was looking at this, I'd probably get rid of the 50% just because then I don't have negative numbers to deal with. So I'm going to multiply everything in my top equation times negative 0.50 or 0.5 if you want to use that. So minus 50F minus 50S equals 50% of 120, give me negative 60, right? So my F's cancel out. 75% minus 50% would be 25% of S. 78 minus 60, going to be 18. And then, of course, I have to divide. I'm going to let you do that for me. 18 divided by 0.25, 72. So I had 72 gallons from my second source. I want to know how many gallons from my first source. I know that the first plus 72 equals 120 because the sum was 120. And so if I just subtract, I'm going to end up with
48.
So not a whole lot different than the ones we just did, just watching on this last part that I have to multiply the percent by my total gallons. So number 14, the Royal Fruit Company produces two types of drinks. The first type is 40% pure fruit juice and the second type is 90% pure fruit juice. The company is attempting to produce a fruit drink that contains 75% pure fruit juice. How many pints of each of the two existing types of drink must be used to make 150 pints of a mixture that is 75% pure fruit juice? So, how many pints? What might I use for my first equation?
T plus B equals 150.
T plus plus B equals my 150 pints of my drink. My second equation.
Um, 40% B plus 75% of B equals.
Whoops. Not 75% B,
90?
90% B. Right, 90% of the second equals,
Is that 75% of 150?
exactly, 75% of my total amount of juice. So if we go ahead and figure out what is 75% of 150.
112.5.
112.5 is how much pure fruit juice we had out of the 150 pints. Okay, so if we decide to solve that by the elimination method, we might multiply the top equation times what?
Negative 40%.
Negative 40%. So negative 0.40t minus 0.40b equals negative 40% times 150.
Negative 60.
Negative 60. So the t's cancel out. 90% minus 40% would be 50%. 112.5 minus 60.
52.5.
52.5. So if we divide that by our 50%, 105. So we had 105 pints of our very good juice. We still need to find out how much we have of the Tropic Tangy. We get 45. Number 15, same kind of thing. A chef is using a mixture of two brands of Italian dressing. The first brand contains 6% vinegar. The second brand contains 10% vinegar. The chef wants to make 320 milliliters of a dressing that is 7% vinegar. How much of each brand should she use? How much of each one? So what's my first equation?
Plus S equals 320.
F plus S equals by 320 total milliliters that I'm going to make. My second equation.
Six percent of F plus 10% of S equals 7% of 320.
Exactly. 6% of F plus 10% of S equals 7% of 320. And if we take 7% of 320, we end up with
22.4.
22.4. So if we solve by the elimination method, we would probably take the top equation times
-6%.
negative 6%, negative 0.06. So negative 0.06 F minus 0.06 S equals 6% of 320. Actually, negative 6% of 320. -19.2. So the F's cancels out. 10% minus 6% would be 4%, so 0.04 S. 22.4 minus 19.2 would be 3.2. So 3.2 divided by 0.04.
80.
S equals 80. So we had 80 milliliters of our second one. How much of our first are we going to use? 140, did you say? 240. 240. So 240 milliliters of the first and 80 of the second. The next ones are distance, rate, and time problems, and they're going to mix up a couple different kind of distance, rate, and time problems together in the same section. Main thing they want to get across is that rate times time is equal to distance. And I want to use that to solve my problems. One of the ones that we're going to be doing is when you're going like against the wind and with the wind, where the rate is either going faster or slower depending on what's pushing against you. It says a cyclist travels 22 miles in 2 hours going against the wind. She travels 42 miles with the wind in the same amount of time. What is the rate of the cyclist in still air? What is the rate of the wind? So I'm going to have two different rates. I'm going to say the cyclist and the wind. And if I'm going against the wind, in theory, I'm going to have the cyclist minus the wind because the wind's pushing against me, making me go slower. If I'm going with the wind, I'm going to have the cyclist plus the wind because the wind's going against my back and making me go faster in theory. So that's going to be my rate. My rate times my time is equal to my distance. So I'm going to take my rate times my time. The cyclist travels 22 miles in 2 hours going against the wind. So my time here, 2 hours. My distance, 22. She travels 42 miles with the wind in the same amount of time. So still 2 hours, but this time I went further. I went 42 miles. So what they're going to do with these ones is they're just going to go ahead and divide by the time right away so that they can get the rates, the variables, by themselves. So I'm going to divide by 2 on both of these. My top equation then, C minus W equals 11. My bottom equation, C plus W equals half of 42, which would be 21. Now I have one of those like we had when we did the sum and the difference were these two different numbers. I can just go ahead and add my two equations together because that's going to cancel out the W's. So 2C is equal to 32. If I divide that by 2, C equals 16. So the cyclist is going 16 miles an hour. I still need to find the rate of the wind. Again, I like to use the one with the plus because then I just have to subtract the 21 minus 16. So if I subtract there, what would I get for the rate of the wind? Five, right? So the cyclist is going 16, the wind is going 5. So usually on these ones, they'll just go ahead, instead of using the distributive property, just divide by the time right away, then it makes it pretty easy to solve. Now the other kind that they're going to do is your normal rate times time equals distance problems where you've got two trains going opposite directions or whatever it might be. Two buses leave towns 228 miles apart at the same time. They travel toward each other. So one's going to go this way, one's going to go this way, and eventually they're going to meet in the middle, or not quite the middle, but somewhere in between. One bus travels 16 miles an hour faster than the other. So one's rate I'm just going to call R. The other one's rate, R plus 16, right? It's going faster. They meet in 2 hours. What is the rate of each bus? I know that rate times time equals distance. So they met in 2 hours. The rate times 2 here. The rate, which is r plus 16, times 2 there. So simplifying that, 2r plus my 2r plus 32 would equal the total distance between the two buses. 228 miles apart. Now I have an equation that should be fairly easy for you guys to solve. So 4r plus 32 equals 228. If I subtract my 32, 4r is going to equal, make Gavin do all the work today,
196.
196. And if I divide that by 4, what was that?
49.
49. I was looking up there and I even forgot it was 49, wasn't it? I probably should have had these other way around because obviously the faster one's going to be the plus 16 and the slower one's going to be the other way. The slower one would be r. The faster one's going to be r plus 16, right? Not that it mattered on solving my problem, but 49 would be the slower one. The faster one, 49 plus 16.
65.
65. And the last one then. 2 buses leave a station at the same time and travel in opposite directions. One bus travels 12 kilometers per hour slower than the other bus. So the rate of one bus is going to be r, whatever variable we decide to do. The other one's going to be
R.
it's going 12 kilometers per hour slower. So r minus 12, right?
12.
And that would obviously be the slower one. It's going 12 kilometers per hour slower. So I have my rates of my 2 buses. The faster one's going r, the slower one 12 kilometers per hour slower, so r minus 12. 2 buses are 654 kilometers apart after 3 hours. So one of them is going 3 times r minus 12. The other one would be going 3 times r, right? So if I go ahead and distribute that out, 3r minus 36 plus my 3r is going to equal the total distance they are apart, 654. So 3r plus 3r would give me 6r minus 36 equals 654. So obviously we need to add our 36. 6r is then going to equal what?
690.
690. And 690 divided by 6 would give me
115.
115. Seems like a lot, but it's kilometers per hour, so hey, it's possible. So the faster bus is going 115 kilometers per hour. The slower one is doing 12 kilometers per hour less, so if we subtract 12, we get 103, right? Sure, you guys are yawning and sleeping and I believe that's the last of that page of homework.